Ladies and gentlemen, thank you for joining us today on our session for data-driven emission monitoring and how the 24/7 monitoring actually is working. Myself, Michael Zudiko, I'm the sales director for optical. This is Dr. Ran Hashmonai, our chief scientist officer. Just a brief info about optical. Optical has been around in the thermal imaging business for the last 40 years, manufacturing different types of thermal imaging devices. In the last let's say 2 decades, we've been concentrating on the industrial application of it, which is basically the OGI cameras and everything that goes around those OGI equipment. Today we're owned by Gavasol company, and they are backing us up and giving us the opportunity to go ahead and advance on, bring the most innovative tools to the market today. So what we are offering to our customers is a different types of solution. We have the handheld solutions for the technician level. We have the 24/7 continuous monitoring solution, as we're going to talk today. The automation software, obviously, and the flying platform with the flying OGI.
And the focus is on solutions here.
Right.
Okay, that's the topic of our webinar today, about the solution, not just about the equipment.
So some of our customers today, and what we can proudly say that they've been using optical equipment. Some of them have installations. Some of them have as I said, fixed devices, and most of them have the handheld devices. You can find here companies from Chevron to ADNOC to ENI to PTT, EP from Thailand, Reliance, Pertamina in Indonesia. You can find Bureau Veritas, Seplat from Nigeria, GAIL from India, Total Energies, and there's many, many more others that are using our equipment today. And I think most of them are pretty much satisfied, and we're serving a lot of the oil and gas community today in terms of the solution to provide to them, and how all of those solutions are basically the major part here. So the advantages of, I would say, the basic thing about the OGI camera and how it works is that it's very easy and it's very simple to visualize those gas plumes, and you don't necessarily have to be inside the plume like this particular technician with this sensing probe that is trying to to identify whenever there is a leak or not. You can just simply set aside in a safe distance and look at the place where the leak is occurring and identify those leaks, visualize them, and mitigate, so that everything is happening in very safe and very quick and very informative mode. So you don't necessarily have to be in the plume in order to identify that there is a leak.
And sometimes you think you find the plume, the source, but it's coming from the other side of this component, and it's not where the highest concentration that you saw with the sniffer. So it's also misleading using just the sniffer. You need to visualize the plume.
Correct. So, and our bread and butter, our flagship is the IC-Gas multi-camera. That's a mid-wave infrared cooled OGI camera that detects methane in over 400 different VOCs. It's been patented for the replacement of the spectral filter technology. And in this case, I do believe this is a very beneficial tool. Maybe you can elaborate a little bit more on the filter side, as we're going to go to the next slide. But the idea is to have a multi-tool that can work in different kind of situation, that can work in various scenarios, detect and have various options of detecting different types of emissions and different types of VOCs or different compounds.
Or distances.
Or distances, correct. So
So
the idea of the distances and the replacing of those filters is actually giving you an opportunity to...
And lenses. I'm sorry to cut you.
No, that's fine. So again, it's also Rams mentioned here the lenses as well, but the idea here is actually to create a tool that will be like the Swiss knife, and you can just open it.
Very versatile.
and you have a lot of solutions in one place. So that's the idea. So we can detect methane in over 400 different VOCs. We can work in close proximity on a long scale, on long range applications, and the detection of CO2 as well, which is also, for this kind of implementation. Some others may ask you to buy 2, maybe 3 different cameras just to make sure you're covering all of the scope, but here represented in one thing. So this camera is super sensitive, and today I think it's the most sensitive piece of OGI equipment on the market. It provides a sensitivity of 0.35 grams of methane with a delta 2 of 2 degrees Celsius. Right, so we're not looking at 5, not 10. We're talking about 2 degrees Celsius. Obviously, if we increase the delta T, it will be even more sensitive than that. But I think it's by far with those numbers below delta T, it's the most sensitive piece of equipment. So even more than that, this device does not require any thermal calibration during, in order to detect gas or during its lifespan, unless you really want that. But the idea here is to create a tool which is not required. Those calibrations, obviously, it's quite a way ENC compliant. It is ADEX proof. It's intrinsic device, so we can work with that in various environments. It has a built-in GPS and all of the memory. It's easily connected to third-party devices, such as, like, I will give you an example. One of our partners is Thermo Fisher Scientific, and they have a very good TVA, toxic vapor analyzer, 2020, that is absolutely connectable, and it's working with those devices superbly. It's very easy integrated to the whole Elder sphere, and all of this alignment allows a very fast and very decent Elder activity. So today we will also have some things that will be impacting the IC gas and the streaming capabilities and how it all works together. But as well, and I would say this is one of the beneficial things, that we always develop more and more advanced solution with this device. So we update the software, we update features, we update different types of calculations, and Dr. Rams here is responsible of giving more and more updates on the quantification.
Maybe I would add that we have a built-in quantification, and it's adjustable and modified to optimize quantification of inaccessible vents or remote vents, and this is perfect for level 4 source level reporting under the OGMP 2.0 framework. And also the camera is very adjusted for the Appendix K requirement. We have a GPS tracking, we have tracking the survey route, and we have delta T measurements, and we have verification videos, capture. We have all kinds of features that we added for, and we have automated calibration, NDT, every time, so it will waive the need to bring cylinders and cigarette lighters into the field. You just need to perform a nuke, and you have a self-calibrated camera. You know that camera is operated properly if it passes the test internally.
So, and where it's very important to actually emphasize those features is with the Appendix K requirements, and obviously with the European Union regulation framework, and especially we're talking about the OGMP, and what is Ramos mentioned is the long-range capability of quantifying those hardly reachable places. So,
and the thing is, another thing that we adjusted, we have the string, the remote string. We'll talk about it when we talk about the application, but this is also something that will really help supervising the operators, the OGI operator under the Appendix K framework.
Okay, right. So as we mentioned, the long-range capabilities, it's not just about the visualization of the plume, or not just about how we perceive and what we can visualize, like in this video from 10 kilometers away, standing on the seashore, just looking at the gas platform and having a capability to to understand that there is a leak and there is a methane event or an emission event, we can also quantify it. But the quantification right now is working on, say, up to 250 meters. That's what I've tried.
It really depends on the size and for example, a small leak we cannot see from 10 kilometers, but the size of the leak, this is hundreds up to thousands of tons per hour. So this is a huge leak. It's all a game between the source emission rate and the distance. Big leaks we can see from far away, and small leaks we'll see only at a limited range. But usually vents are in the kilograms per hour, not in grams per hour. So we can see them from hundreds of meters away.
So in that case that we, don't use or cannot access, we can visualize them, as well as our flying platform that allows us to go to those farther reaching places or to pass through a long, let's say, land or sea-placed pipeline, which is not reachable, using the SkyCube drone integrated with our OGI camera allows us actually to achieve those. And in the next stage with that would be the autonomous feature.
And also Quado require or suggest that companies can offer a screening methane emission screening tools, and the airborne OGI on a drone is the perfect match to this requirement. And instead of people on the ground, they can cover a lot of well pads and compressor stations using the airborne and do it and waive the need to do the detailed LDAR in these sites.
All right, so all of that is supported, both the flying application and today the handheld devices. They are all supported by our mobile app, which gives us the solution, actually the manipulation, and give the ability to control the devices. And we're talking about, first of all, the streaming capability allows us to bring a direct streaming from the operator holding that camera, right? And he can stream directly to another place whenever it is in the world, unless they have an internet connection. Obviously, that's a requirement. But the idea here is that, for instance, like in the Appendix K, right? You have to go through this meticulous
auditing,
exactly.
By a senior operator that needs to audit a junior operator. It should be done semi-annually, and they give in Appendix A 2 options: either walk through behind him and do it on the ground, but the other option is to record videos and after the fact.
But that's not immediate, right?
But we can offer in intermediate options that saves a lot of time and money, that the senior auditor can walk through remote streaming and give feedback to the operator, to the junior operator online, and perform it as if he was there on the ground.
Right. So the app will also, at the first stages right now, it's not ready yet, but it will come. It will perform a full quantification sequence. So all of the plume colorization and the quantification and the reporting things will be happening on your phone through the app. So you can right away get the report and actually use them or share with them if you would like to. And that's a major thing here. That's a major feature that allows faster activity, faster deployment, faster reporting, and obviously faster turnarounds.
And supervision,
of course. So the supervision is the basic fact. So the app will be available soon for, and I hope like within the next week or so, we're going to have the app, right?
Yeah.
Uploaded to the Google App Store, and for the iOS users, you will have to bear with us another 2-3 weeks or so before we finalize the bureaucratic process. But you will also have an access for the iOS devices, and you'll be easily going through that process, and hopefully it will be a super helpful. So we're just going to talk about a little bit more about the regulation, about the EPA requirements, about the European Union requirements, about the OGMP 2.0. So now it's yours.
Yeah, so EPA is mainly talking about the Appendix K under the Quad B, Quad C 2024 regulation. They are required actually to do the LDARs using a portable OGI, and they offer an opportunity also to combine continuous methane emission monitoring with a fixed system, and also a mobile airborne screening tool that do the whole site remotely, like in the icy gas fly. So there are opportunities in the new regulation in the US to deploy OGI in all the platforms that we have to offer. And we, in our camera, we did everything. We checked every line in Appendix K, and whatever we could change in our software or in our app, we updated and upgraded to match the requirements of Appendix K, which is actually a method, an EPA method, how to perform an OGI LDAR. So, and in European that follows the OGMP, this is our quantification, source level quantification. That's where the OGI is very strong, and especially our OGI, we focus on remote sources that are usually the larger sources. They are the main sources at every facility, like vents, elevated vents that are 100 meters away, and we can do it on any sky background. We are developing our quantification to give the most reliable remote, and we added a feature in our camera recently that any screening quantification, the data file is saved on the camera automatically, and you can upload it to us, and we can give you feedback on your quantification surveys, train you online, and validate your numbers before you report them to the OGMP framework. This is very important because this type of software is require, if detection require 1,400 hours to get to be a certified senior OGI operator, quantification, you can double the hours of experience. So we cut these experience hours by giving you feedback and train you online really fast. You back and forth send us quantification data files, and we can give you feedback on how you do it, and are your numbers are accurate, and what is the uncertainty. And this lead us to our next generation 24/7. We are trying. This is source level quantification with the portable camera. We are moving into site level emissions, which is level 5 of GMP reporting, and you need to reconcile your source level with the site level. And we would like in the near future to offer a full solution that covers level 4 and level 5. We're going to do the site level by continuous monitoring, by flyovers with our drone mounted OGI camera, and we're going to use other monitoring and plume characterization techniques to provide a full solution to our clients.
We shouldn't be disclosing everything.
No,
we have to keep a little bit of
in the next slide anyway.
So the idea here is, first of all, is Dr. mentioned, is to create a validation platform that will allow to have those videos and to the data collected, to have that really have the scan that it passed through all of the meticulous checks, and the data is realistic, and not just a random number throw. This is might sometimes happen in case of
misuse of the software,
mistakes during the data collection. Correct. So In that case, it's very important, but also there are going to be additional surprises into the automated processing and how we're going to do it. But that's about the point where we start to talk about the senses, sentient, and actually to, to kind of remind what are those, how they are implemented. So just a few words on that. And then the idea here of this product, which is an inclusive platform that is using OGI cameras, but it will be also using different sources of data grabbing from sites, utilizing those into creating sort of not a spherical and a dome-like, but a holistic system that will be that is designed to collect various data from the various methods that are already existing or might be added to those in combination with the OGI cameras that are visualizing all of that. And that's the whole idea. So the whole thing is going to be dynamic. It will be edited to every site, and it will be a machine learning process that we will create or we will initiate with the
Be
site.
optimized over time.
Correct. So they're learning the regular schematics of work. They're learning the let's say permitted emissions. They're learning the routine works, how the emission is going on site. Right, taking all that to consideration, we might use some gas sensors, some ASPODs, some different type of equipment, laser equipment that you might have on your site. So all of it connected to this one database, including the OGI for the visualization, to create a sort of a dashboard for all of the emissions during the daytime, during the nighttime, operations, stop, so on.
So I just wanted to add, we will present an example that actually demonstrate this importance of doing different sources of data to get a complete picture. And this is we already started this process about 2 years ago, and we'll give you some data and explanations on these case studies that we're going to show in the next few slides. So
yeah, we're taking the human precision and adding in the AI vision, and then you have the
and data from many sources, not just the OGI cameras. If we look at this slide, you don't see specification. It's not Sentinel-24 is not a specific camera. It could be MWIR, it could be LWIR, it could be different lenses. Yeah, it could be for sight. It could be we can use 2 cameras and do some triangulation from 2 cameras, computer tomography in the field. Everything is possible here. We are in the first step of redesigning, and we're going to work with our partners and our clients to every site. We have a different problem. For example, we just going to install in a refinery an MWIR camera to cover ranges of half a kilometer to the sources, but in another site, which is olefins, we need to measure ethylene, so we don't need to have a cooled camera. We can use an uncooled camera on distances of 50 meters, not more. Yeah, yeah, 50 to 150 meters, not more, but we fit the technology to the need and to the solution that we are trying to resolve. And if we need to connect our system, our platform, our dashboard, as you call it, to on-site connectors, to operational data, to sensors that we bring on-site with us for providing this solution, we'll do that.
Right. So this can be applicable to various platforms, obviously for upstream, when we do have a lot of methane emissions or a lot of natural gas emissions or natural gas operation structures. That could be one design or one style of operation for the VOCs, or let's say refineries or downstream, all of that things that will be a slightly different application. But yet again, we're going, the cameras themselves is just a tool to get to the result, which is the system and their specification. And of course, the next step that we're going doing trials right now, we're talking also about ammonia. That's not relevant, but those are three major, let's say, ways or segments that we are concentrating on and trying to provide the best results so far. It looks good. So, Ron, I'll give you the floor to talk
So we already started this several years ago, and what we've learned by doing 24/7 automated detection, OGI camera, and when we rely only on the camera, we have an issue that OGI camera strongly rely on the environmental conditions, humidity, visibility, angle of sun, clouds coverage, and mainly the delta T that we observe, the apparent delta T that we have between the background and the air that actually determine our sensitivity. So different time of the days, we will have different sensitivity. So relying on a full solution that rely only on OGI camera, nothing, it's only one pillar of the full solution. We recognize that we need to add more data. We need data on speciation. We need data on measuring real concentration in different places around the facility, and fuse, get a unified solution of all of that information to provide what needs to be provided. Usually is when you have an emission event, you need to have an alert. You want to know where it's coming from. You want to know what it is.
You need to extract it.
Yeah, well, that's the. Usually you don't care, but from the site facility, you want to know what it is, and eventually you want to know how big it is.
But that's an interesting question because, look, for example, if you have two facilities near to each other, there is a small paved road that divides them, right?
Yeah.
And there is a laser detection system, right? On the fence or fence line detection, and then you suddenly have alerts, right? But those two can bring the alerts. So even it's you or it's your neighbor that throwing with the wind, down the wind, the whole thing. So it's very important to have a full picture, at least to have a design or understanding of mapping.
We reached a conclusion that we need to redesign our thinking about it, and we include any data. That's the title of our data-driven to actionable what? I don't remember. But the idea is that we use any data that we can, and the system layout is the general layout. It rely on OGI automated on a pen and build camera, but also we have alerts from different sources, and you can see on the left side we have a PID, a fixed PID over there. It's called ASPOD, and this could provide alerts. So what? Can you go to the next slide?
Yeah. I wanted to show the ASPOD.
Okay, you measure wind speed and wind direction. You measure any data source that can complete and complement the picture of your emissions. What I said, when, what, where, and how much. These are the things that the site managers want to know in real time. So this is an example, like a case study of our installation that we installed on 2 years ago, 2024. And in this installation, we actually rely on an existing 60 compound O2GC. Can you point to the so for a second? Can you point with the mouse to 60 compound O2GC station over there, which is downwind from this big industrial complex. And the Sentinel 24 is sitting in this location on the bottom left of the picture and can scan the whole site and see emissions coming from there. So the alerts in this setup are coming from the 60 comp only when the monitoring station, total VOCs is above a certain threshold, and we do some calculations of flux crossing this station. We send an alert, we turn on the camera, and actually by doing some kind of triangulation and inverse modeling, we can say, or compound analysis, we see in 60 compound, we see which compound are dominated the plume. And by knowing the composition of the plume, we can guess from what part of this facility these emissions are. We combine it with wind direction and wind speed, and we direct the camera, the OGI camera, to the location. We do a secondary alert by the OGI camera, we color the plume, we send an alert, we tell them where to go, and it's like what we call a real-time root cause analysis. So we have the primary alert from the sensors, turn on the camera, direct the camera to the suggested area of the emission, scan it, detect it, and send a secondary alert. Yes, we saw it, and record the
colors.
but which colors?
The colors of the gas.
Okay, we color it. Yeah, we color it. But what I think is important that we record it for evidence, and we can also use the quantification of that plume, of how much, not just relying on the OGI. We have data also from the concentration downwind, so we can quantify in two independent methods, and converge this to one more accurate quantification. Because when you quantify with OGI, you need to know what is the compound. If you don't know what the compound, your quantification will not be accurate. So you don't need to have 60 compound monitor. You can have a PID that measure total VOCs. This is the SPOD. It's developed by US EPA. And one of the things is, if you want to know with the SPOD what is the composition, you can have an automatically triggered Suma canister that can fill in 1 minute the gas during an event measured by the PID. And then you send it to the lab and you get the composition of that event after a few days, but and then you can use it with the machine learning. You can teach your system, oh, the wind direction was from there, we got this composition, the wind direction from the other direction. And then your whole system of monitoring, recording the plume, the colored plume, is getting better and better and optimized over time once you install it. But this PID is a low-cost sensor. You can have many of them. Occasionally, you can sample the composition when you have events, and you have the complete picture without, spending a lot of money on monitors. But in some sites, some sites already have benzene O2GCs, BTEX O2GCs. They have all kind, 1,3-butadiene O2GCs.
Plug in.
We will plug into any information that the site have. We will add our SPODs. In case of methane, we will put methane monitors. It could be laser-based or MOS, metal oxide, I'm sorry, metal oxide based, but any low cost or reasonable cost sensors will bring the all Sentinel-24 to another level of accuracy, triangulation, and video of visualization of the plumes in real time.
So correct. So we're just like learning the patterns, learning about the compounds, learning to color them, learning to map them. And basically we're teaching our system like an process of a child learning, right? So he gets his few steps, then he falls, then he has like 5 steps, then fall. But eventually he learns and stands alone. And after some period of time, and that period of time is basically designed or dictated by the site size or by the site or by the definition of the equipment that we have. But the more information you have, the better the faster the results will be. This is
and we are open. We keep our mind open. We listen and see. Each site will have different motivation to do this, and we listen, and we're trying to provide the most cost-effective solution, but reliable solution where we can really. So this is in 2024, right after the installation. You can run the movie on the right. Yeah, it's a movie. I think it's a movie.
No,
No, it's not a movie.
No.
It's a still. Oh, this is a movie. Okay, okay.
Video.
It's a video. You can see it's coming. You can show them where it's coming. You can see it from the left side at the bottom.
Yeah. The
Uh,
event is actually here.
you can see on this picture where the event starts. But,
Yeah. Okay. I'm moving my cursor, but there is another one stuck on the screen. So.
Yeah, this is from the video. Yeah, right here, where this is the source. It's being colored by green, and it's coming and it's moving to the right side, and it's crossing. So when we detect this 2 years ago, the 60 compound was not installed yet, so we had to guess what gas it is, and we did some quantification. We did vertical profiling. You can see the graph over there of the CL concentration. We integrated it. We used the wind speed and wind direction. You see the plume is crossing this vertical plane over there. We used these pixels in the image, and we estimated it to be 270 kilogram per hour, assuming it's N-butane. Okay, move to the next one.
Yeah, I just wanted to ask about the dots, what we see on the screen.
Okay, this is where we do the CL quantification.
Perhaps the gentlemen and the ladies here are curious about what are the dots.
Okay, this is not part of our client software. It's our internal research software, but this is so. A year later, in April, May, you can see in May 6. You can show them in May 6 over there. The blue line is the fluxes that we measure in the 60 compound.
No, the 6.
Total VOC fluxes. You can see first order flux calculation. And you can see that on May 6 until May 12, we can see an increase in the level of emissions. So, and before that, the levels are much smaller, and we do an estimate of kilogram per hours, but you can see that the numbers of 270 kilogram per hour is very similar to the order of the quantification that we see from the downwind station. Can you move to the next slide? So we did it, the same plot for benzene, for example, and we cannot see some before May 6, you can see that the events are also large for benzene. You can see the fluxes are much smaller. They are around 1 kilogram per hour, not hundreds of kilogram per hour, but the total VOCs are much larger, and you don't see a difference. When you have a huge increase in total VOCs, it didn't drive any increase in the benzene monitoring. That means that are not always associated with each other. So important to know that when you measure total VOCs with the OGI, you want to know what is the composition, because it tells you a lot about where to find the leak and really have the evidence of the smoking gun. Okay.
Yeah.
So this is an example on the same site and same location. We use SPOD with AutoGC, and the purple line is the AutoGC total BTEX, which is part of it is benzene. And you can see you have these events of total VOCs, and they're not always correlated. Sometimes you have total VOCs and you have nothing on the BTEX, and sometimes when you have the BTEX, you usually also measuring the SPOD, also measuring the BTEX. So when you have BTEX, the SPOD will respond always. But the thing is, it's not right vice versa. When you have a total VOCs, sometimes the BTEX does not respond. But when you have one AutoGC just measuring benzene and an SPOD coupled together, you already know so much about the plume. It can differentiate between two adjacent sources, and it can tell you if it's coming from that general direction, but this one has benzene and this one doesn't have benzene, you can do the triangulation, not just relying on atmospheric wind speed and wind direction. You can use the composition information to, can you move to the next slide? And so I just want to walk you through about these 60 compounds. By the way, I didn't mention that the red line is the wind direction. And you can see, can you go to the previous two slides? This one, you can see whenever the wind is around 300 from the northwest, you have an event from this facility. Go another one back. Every time we have 300, where if you look at the map, northwest is the location of the facility. From the monitoring station, you have an event. Every day, almost.
So it's also like some sort of coordinating tool that gives you the direction, the wind,
Yeah.
especially.
But we are not using just wind speed and wind direction, we use also the composition. So go to
Last.
so I want to go to one previous.
Sorry.
Okay, you have three events that I want to do a case study. You have one on April 14, one on May 7th, and one on May 11th. 1, 2, 3. Let's go to the first one. The first one is when the wind is westerly. So
We need to go to the first one, which is,
the next line.
No.
You're going back.
I'm sorry. Okay, sorry.
This is the first one. The wind is southwest-west on May 14th, and you can see this facility on the south side of this facility is olefins. And the emissions, you can see the composition from the 60 compound station is mainly ethane and ethylene.
Contain.
No,
The other.
58%, 59% and almost 40%. So we are talking about almost 100% of the emissions are ethane and ethylene. So we know it's pointing, even if we didn't have information about the wind, we would guess it's coming from this olefins place. And go to the next one. And what I want to go to the previous one for a second. What I can show you here, benzene is not part of the plume. Now the winds are more northwesterly on the second event, and you can see almost 70% is isopentane. And you have cyclopentane 11%, so it's about 80, what is it? 80% a form of pentane coming from this facility. And the rest of it is in much smaller amounts, and you have butane. 85% is alkanes between 4 and 5, and the rest is really small percentage proportion. So go to the last slide. So, and another one a little bit north of that, again, you see the same picture. Isopentane and isobutane is already like 80%, and the other compounds are much minor from that facility. So this composition with this associated wind direction can tell us where to direct our camera in these three events. And we can use, if we didn't have AutoGC of 60 gases, we could use S-pods around the facility with some other Sume canisters sampling, or simple AutoGC that they measure one compound or two compounds, and we can.
So we have trigger, right?
Yeah, we need some more information than just the total VOCs that the camera and the S-pod give us. This is, if you have just the S-pod and just the camera, it's very hard to tell where it's coming from. You don't have any information about the composition, and people
need to search for it.
Yeah, and we can upload to our system also the emission inventory to know which compound are coming from each site. And this is part of the machine learning and optimization for each site. Okay, can you move to that? This is the last event. It's happened on May, just a year ago. This one and immediately the other one. So this is event from a 4 kilometer. This is an upwind from that refinery that you show you. You can see the plume coming. This is an emergency flare that explode every few minutes. It's exploded, so you will see the explosion. But you can see the plume, and you can see our system car of the plume. It's moving to the east, but this is 4 kilometer, and that plume is going from the west side of the refinery across the refinery and reached 5 kilometer downwind to the 60 compound monitor station. So go to the next slide.
All right, I just wanted to see the.
Oh, this is the explosion. You see the explosion? And
Right, so basically you would like to identify those before it happens. And the idea here is that in that case, we understood that, particularly in this thing, the refinery had nothing to do with this event. It just happened to be their neighbors.
and I tell you that the operator, our client, what he did, in the visible camera, all the people asked, "What is this explosion?" They heard it, they saw it, huge plumes, huge fire. So they aim manually the camera. This is another feature. Our client can take over the automated system, and they aim it to that position and take about 2 hours video of this event while it lasted. But the most important thing is we have also this. On the left side, we see the composition at 1:30 p.m. The event happened around 5 o'clock in the afternoon, 17. And in 13:30, we had the regular isopentane and cyclopentane emissions from the refinery.
Yeah, we had spikes already.
Yeah, you had spike from the regular spikes on May 18th, that every day when the wind is northwest, we see these spikes. But what happened at 6 o'clock, you can see the composition totally changed because of this event upwind that came from 5 kilometer. Now we have isopentane went down to 20, from 65% of the plume to 19%. So, and you can see you have 1-butene, you have chlorinated compound. So, this is a case how the speciated can really pinpoint where it's coming from.
Right. So as long as you can pinpoint it, obviously you can do the preventive measurements, or can do preventive action just before the bad things is happening. So not talking only about safety, but having a full idea, the full scope of the emissions, having the spikes and here and there can tell you a huge story. And that's what the system, what Ron just did, describe to manually part by part. Normally it happens fast, like the reaction of the software is way faster than just the explanation. So, and that's the idea. So,
in summary, what I would like to say, we tailor a solution that is based on OGI, automated camera. It could be also airborne cameras, part of the solution, portable cameras, everything. But as you can see, having information about the composition of the plume, having low-cost sensors that complement the whole system, give you much more accurate and reliable data as a full solution system. And that's where we are going to. And each site, each client, we will tailor a solution to their needs. And then we always keep in mind to keep it cost effective. When you replace low-cost sensor with an additional camera, we will have less. We will always find the balance between all hardware and.
we're always, as equipment manufacturer, there's always the idea, you have to have a lot of cameras, to cover everything, put as much cameras as you can. But then the idea is that the customers, they have budgets and they have to implement this technology and to be cost effective. So maybe by placing two very cost effective gas sensors, it might disqualify a need to have another fixed camera there. So the idea is the combination of all of the features. So it could be cost effective, it could be precise, it could be directed to the exact point. So all of those features, including good visualization and alerts, and obviously all of the reporting data, which is super crucial for all of the site level reporting and then reconciliation with the source level data, including that, the, like Ram said, the flying drone or the flying camera that will also will be a part of this scheme of the protection scheme or the monitoring scheme. Would add another layer, but at least another coverage, field of coverage that will get you more and more technologies implemented, and all of that is rooted to this computer that can do that, and that's the idea of the Sentinel. So, thank you very much for the detailed explanation. And again, if you have questions, that's about the time. And
maybe you can put the questions on the screen.
Well, yeah, I will stop sharing, so it will be only us, myself and Ram here. So thank you very much for your attention on this matter, like the president said. So, yeah, we're gonna go back to the visual part and we're gonna stop sharing. So I can see there are some hands raised. There's some hands and questions, so please feel free to address them. The one is coming from David Thomas. No, I'm sorry. The first one was from Jared James. For the 24/7 monitoring, have you trained artificial intelligence to recognize gas leaks, gas venting, and flame presented on vapor combustor / flares? Then AI can notify facility operations. So it's an automatic response.
Yeah, we use AI, but not only AI. We have some physical ways to differentiate between steam and in gas, and we use multiple cameras, multiple channels, visible cameras. We use all sources. Also on the recognition of the gas plume, we use different sources for data to get more reliable alerts on the gas.
And that's actually leads us to our next question. So what is the level of uncertainty in the quantifications on those kind of quantifications?
It's a very complicated answer to a very simple question, but it really depends on the conditions. But a lot of the uncertainty, as we mentioned before, comes from the user. We can reduce the uncertainty to a level of 20-30% if the data is safe and we do post-analysis on the event of quantification, and we make sure that it was done properly and was all the input information is entered to this software properly, and then we can reduce the uncertainty to 20-30%.
If you have sensors implemented, right? So you obviously will increase your, decrease your uncertainty, and you will be more aware of the picture.
Yeah, but in the automated, I thought this question was about our QGI. About Sentinel-24, yes. The more sensor, the more data that we have, independent data from different sources of data, we will reduce the uncertainty, and it cannot be. It really depends on the application, the compounds. It sounds very simple because we don't offer a camera and one software and one compound. I don't have one answer to this question. So it's a topic for different
for another webinar. But let's put it aside and have another point here. Perhaps we can focus it on the next one. So we also have here another one. We at Alpha Designs, Nigeria Limited, already testifying the capacity to perform up. Thank you very much, Alpha Designs.
It's a comment?
Yeah, it's a comment, yeah. How will the customers will be notified of the updates of the OGI quantification algorithms? Well, I guess it's automated. No, I'm not guessing. So I'm telling you that it is automated. As long as the system have longer performance period, the better the algorithm will become by itself as a machine learning.
Site specific.
Yeah, specifically for site. But then there is information that we're grabbing from other installation, and the let's say the patterns or the repeating patterns that might be found and might be relevant to that site. We can again reconcile this data and help to the system to work faster by using the data already captured from another side. So that's something that is, is more we have, the better it gets. Although sales staff in the US stated quantification results are not accurate for field-based measurements, they recommend using a high-flow sampler to quantify gas leaks and vents. Can the quantification be used for USAP Aqua B compressor vent flow measurements? Okay, so may I have this one?
Flow measurement?
Right. So the idea here, if we're talking about vent flow measurements, then obviously that's something you cannot put your high flow sampler on, because the vents are normally located on some remote place, and you would need a physical contact with the vent to get there. So it's very similar to the project we're doing with the OGMP, and I would not name the customers, but we're doing right now very interesting thing, and it's the second time we're implementing this kind of thing. We're using the long range camera with the long range lenses to get an access to those remotely placed sources and to have a quantification. And this data is actually very, very reliable as long as you perform everything according to the guidebook or to the guidelines, which obviously is dictated and then validated by Dr. Rami.
Yes. No, by automated platform.
Yeah, I mean, it's your platform eventually, but yet again, that's something that is. So we're back here for Dave Thomas. Okay, so how many 24/7 monitoring systems you need to control a gas treatment plant? And it says, the question is whenever the monitoring system is have enough accuracy to quantify. Yeah, it quantifies. Otherwise, it's not going to be coloring and not, having the event as located event. So it is doing the quantification, and it is actually doing all of the automated processes and provides the report on those events. Otherwise, you will not be seeing the lines and the show. So it is Peter Cheney. Do you want to have another question, or the hands is raised for?
I think we have time for one more question.
Okay. So, Peter, if you want to, I don't know if you can, you want to drop us a message on the chat box. So we're going to have another few minutes, as we're a little bit running out of time, but another question, feel free. I hope you gentlemen and ladies enjoy the show and enjoy the. Oh, it is.
You can.
I have one more. So, is it possible to achieve a full site level measurement using the continuous monitoring system? And can the data generated be used to reconcile level 4 for the LGMB 2.0 and level 5 reporting?
Yes, with the right design of a combination of low-cost monitors and OGI cameras, we can have a site-level system that it's not just reconciling source level to site level, it's also reconcile short-term emissions to long-term emissions. It's getting more and more complicated. I think we'll see, but yes, we can cover a full site. It really depends on the size but the option to put other sensors beside OGI offer you a more cost-effective solution and reduce the number of cameras.
So, let me see if there's another question of somebody typing. Okay, so ladies and gentlemen, thank you very much for your time, for your efforts, and thank you for being with us today. I hope it was impactful and was informative for you, and we're always here to provide any answers or any requests or any information, additional information on how the system works. Myself, Dr. Akash. So it was a great pleasure.
Thank you very much. See you soon.
Take care. Ciao, ciao.
Bye.